Hello, campers. Now, let's tackle these questions here. So, consider the matrix A, as you can see here, which is A, B, C, D, and matrix B, which is 2, 4, 6, 8. Given that matrix A has two diagonals, identify the elements or entries in each diagonal. So, remember we spoke of matrix having the diagonal for a square matrix. This is the leading diagonal. Okay, this is the leading diagonal. So let's identify the diagonals, the elements in each diagonal. So the leading diagonal Alright, so the elements in the leading diagonal would be A and D. It said to list it, so we're going to list it. And non-leading the elements in the non-leading diagonal would be what? We see C and also B. So we could say B and C. Alright. Next part says state the product of the two elements in each diagonal identified. So the product could be in the leading. What would be the product? So leading, we say, so product of leading that would be what? Elements are A and D, so the product would be A times D. Or you could say AD, same thing. And the product of non-leading, let me write product here and then shorten it there. And that's B times C, or BC. If you want to say BC or AD, it's the same thing. Okay? Alright. What is the difference of the result obtained from this? Okay, what's the difference? The difference is actually AD minus BC. So that would be the product, the difference of the product. Okay? Yeah. So that is for part I. Part 3. This is part 2. This is part 1. Okay, I believe that is clear. Alright, now it says evaluate. So given that we know what A is and we know what B is, we should be able to evaluate. So let's add those matrices. So matrix A, which is A, B, C, D, we're going to add it to matrix B, which has the elements 2, 4, 6, 8. So what would be our result? Simply A plus 2, 4 plus B. Here we have C plus 6 and 8 plus D. Whichever way you have it, remember addition is commutative, which means it doesn't matter the order. So if you have 2 plus A, and here you have B plus 4, and here you have 6 plus C, or D plus 8, it doesn't matter. Same thing. Okay? So that will be the result for that. What about A minus B? It's the same thing. Alright, so we're going to subtract. And remember the rule of subtracting matrix. You subtract the corresponding elements which belong to the same position. So same thing with addition and subtraction. Add the elements in the same position. By subtracting, we subtract the elements in the same position. So we will end up with, as our result here, we end up with a minus 2, for here b minus 4, here c minus 6, and d minus 8. Alright. Okay. Alright, so what is negative b plus a now? Let's do that over here. Have a little space there. So b, negative b minus, sorry, plus a. So remember, negative b is basically finding the negative of b, which are the elements 2, 4, 6, and 8, plus a. We know the elements are already a, b, c, and d. So if we were to add these, remember, if you find the negative of a matrix, that is like multiplying the scalar negative 1 times all the elements in the matrix. So find the negative of the matrix. So it's basically multiplying by the scalar negative 1. So this would be negative 1 times 2, which is negative 2, negative 4, negative 6, and negative 8. Because negative 1 times all of those elements will give us these here. And what would this result give us afterwards? This would end up being negative 2 plus a, negative 4 plus b, negative 6 plus c, and negative 8 plus d. Alright, so what's that? Now, they're saying to find the result of a plus b minus a minus b. We already did a plus b and already did a minus b. So all we need to do now is to subtract them. Alright, so let's see what that would give us. Let's do that one here. Alright, everybody following? Look. Okay, so we will end up with a plus b. Remember our result was a plus 2, 4 plus b, c plus 6, 8 plus d. So let's write that. So a plus b, which was and now they're asking us to subtract a plus b. We must subtract from that a minus b. And our result was alright. So that was our result. Now it's time for us. What do we get as a final result? Remember, if you're subtracting these, what will you end up with? So subtract a from a, that would cancel, and this would be 2 minus a negative 2. So that is like adding. So let me write it out for you so you can see it. So this would be A plus 2 minus A minus 2. Alright, because we're subtracting all of that. Okay, let me write the other one. This is B plus 4. Alright, minus B minus 4. And this one here is C plus 6 minus C minus 6. And this one here is D plus 8 minus D minus 8. Alright. Now, let's use a different color to identify what we're doing here. So let me zoom in. So look at what will be our result. A plus 2 minus A minus 2. Now think about this. This is minus A, and this will be negative times negative, give you a positive. So we end up with A minus, so A plus 2 minus A plus 2 again. How did we end up with a plus 2 again here? Because remember that when you have a negative of a negative, we get a positive. So a negative times a negative will give you a positive 2 here. So when you're ready to subtract now, alright, this 2 would cancel. We end up with 2 plus 2, which is 4. So that will be our first element there, 4. Alright, our next element, same procedure. This would be B plus 4 minus B plus 4. So this will cancel that. 4 plus 4, 4, 8. Alright, this would be C plus 6 minus C plus 6. So that will cancel. Sorry, that will cancel. Let's see. So we're left with as our result here 6 plus 6, 12. And here this would be D plus 8 minus D, because negative times D gives us a negative D, and negative times a negative gives you a positive, so that will be plus 8. So when you subtract D, these D's, you end up with 8 plus 8, which is 16. So what is therefore our elements for that? So therefore, for question IV, the answer is 4, 8, 12, and 16. Understood? Alright, let's move a little quicker. Alright, so based on your answers in 1B, can you conclude, what can you conclude about A minus B and negative B plus A? Now if you look at it, A minus B was this one here, which is A minus 2, B minus 4, C minus 6, D minus 8. And then negative B plus A give us this as our result. Negative 2 plus A, negative 4 plus B, negative 6 plus C, and negative 8 plus D. What do you notice about these two? They are the same. Alright, A minus 2 is the same thing as negative 2 plus A. Alright, the 2 is negative here, and the A is positive. 2 is negative here, A is positive. Likewise, the C here is positive, the 6 is negative. 6 is negative, C is positive. All elements of Boothe is the same. So they are equal. So that's what we could conclude. They are equal. Alright, and then finally, let K be a scalar quantity. such that A equal K times B. Determine the value of the constant A in terms of K. So, the constant. So remember what A is, so we're going to do it here. Alright, we didn't write the answer. They are equal. And then question D now, they told us that A is equal to KB. So therefore, if A is equal to KB, we could say, remember what A is? A is equal to A, B, C, and D, right? And the KB, which is a scalar, multiplied by the matrix B. So that means if the matrix B was 2, 4, 6, and 8, KB would mean 2 times K, which is 2K. So let's write that. 4K, 6K, and 8K. Why? Because if B is 2, 4, 6, and 8, let me remind you what B is. See there? B is equal to 2, 4, 6, and 8. That means KB, which is a number multiplied by B, a scalar number multiplied by B, KB would therefore be, as we see here, 2 times K, 4 times K, all the elements times K. Alright, now they ask us to express A, the value of A, which is this value here, A in terms of K. And there it is. So therefore, we could say that A is equal to 2K. Alright, that's it, campers. Yeah.